5, 4, 3, 2, 1.
In the PowerPoint for Chapter 8.1, you will find definitions of scalars and vectors. The first question is to explain the difference between scalars and vectors, giving examples of each. Well, very simply, a scalar is a quantity that has size but no direction. It's fully described without any reference to direction. A vector quantity, on the other hand, has size or magnitude and direction. If direction isn't given, then the quantity is not fully described. Here's some examples of both for your reference. Second question. Consider the motion depicted in the diagram below. A physics teacher walks 4 meters east, 2 meters south, 4 meters west, and finally 2 meters north. Part A. What distance has the teacher walked? Well, distance is the total length of the path travelled. So all we have to do is add up those 4 distances, and the answer is 12 meters. For part B, displacement is the change in position. So we're looking at the difference in position from the start point to the finish point, and if you interpret the question carefully, you'll notice that the teacher ends up back at exactly the same place, which means the displacement will be 0 meters. There's no need to talk about direction here because the displacement is 0. The next one, what is the displacement of a cross-country team if they begin at school, run 10 kilometers and finish back at school? This is another example of finishing at the same place you start, which means your displacement is 0 kilometers. Example 3. A cat climbs up a tree, a distance of 1.5 meters, and then becomes frightened and edges 60 centimeters back down. Alright, so we need to draw what's called a vector diagram. Remember that vectors are drawn using an arrow. The length of the line indicates the size or magnitude, often to some scale, and the arrowhead indicates the direction. So we start by drawing an arrow showing 1.5 meters up. Then the cat comes 60 centimeters down, but we have to change centimeters to meters to keep the units consistent. So the actual displacement of the cat will be from its start point to its finish point, shown with the red arrow or the red vector, and that gives a displacement of 0.9 meters in the direction of the arrow. The resultant vector is always drawn from the tail of the first vector and ends up at the head of the last vector that you are adding. So B, the distance, is of course 1.5 plus 0.6 meters for a total of 2.1 meters, but the displacement from the diagram is 0.9 meters, and remember a vector needs to have direction, so we must give the direction. In this case it's up. The change in position is 0.9 meters up.